Science Journal for Kids and Teens presents How Can Humans and AI Work Together to Detect Deepfakes? Read by Miranda Wilson. Abstract. Fake news is not new on the internet, and people often change images and videos for a joke. However, deepfakes aren't only meant to make you laugh. Instead, they can spread misinformation or discredit a person or a group. As more deepfakes find their way onto the internet, we need to find the best way to detect these harmful videos. We tested whether the leading AI model or humans were better at detecting deepfakes online. We found that humans and the AI model were each good at identifying certain types of deepfakes. Maybe we could merge the abilities of both AI and humans to create the best deepfake detection model. Introduction. Imagine you are watching a video online of your favorite celebrity and they say something very offensive. You might be shocked or maybe even angry, but you have a feeling that something is wrong with this video, and it turns out it's a deepfake. For a long time, video evidence has been the best way of indicating whether someone did or said something. Unfortunately, the rise of deepfakes means that this is no longer the case. Deepfakes are videos that show people saying or doing things that didn't really happen. These videos are created by an artificial intelligence, or AI system, based on deep learning, leading to the name deepfake. There have been a handful of deepfakes that have gone viral in the past few years. These include videos of well-known figures like Barack Obama, Donald Trump, and Mark Zuckerberg saying things they didn't say. But can we tell the difference between real and fake videos that we see online? Engineers have trained machine learning models to try to identify deepfakes on the internet. However, the best known model can only detect deepfakes with around 65% accuracy. We wanted to know whether humans or the latest machine learning model were better at detecting a deepfake. We also wanted to see if human emotion plays a role in our ability to tell what's real and what's fake. We then used our results to suggest how best to detect deepfakes online. Methods. We designed a website called Detect Fakes, where anyone could view deepfake videos. We used this site to test how accurately ordinary people could detect a deepfake. Most of the videos were of unknown people making unimportant statements. That was to make the experiment more equal between humans and the machine learning model. We conducted 2 experiments. Experiment 1, one real and one fake video side by side. All participants in this experiment found the site while browsing. They watched a deepfake video alongside its corresponding real video, and we then asked them to choose which one was fake. There were 56 pairs of videos. We examined the accuracy of 882 participants who watched at least 10 pairs of videos. The machine learning model assessed all 56 videos. Here in Figure 1 are 2 images used in Experiment 1. One of these images is from the original video, and one is from the deepfake. We asked the participants to identify which of these 2 videos was the deepfake. Can you guess which image is the deepfake? Experiment 2, one real or fake video. We had 2 kinds of participants in this experiment: people we recruited and people who found the site while browsing. We focused on participants who had viewed at least 10 videos. In total, there were 301 recruited participants and 1,879 non-recruited participants. Our recruited participants started the assignment with a writing exercise. Half of them just had to write about their day. The other half had to write about things that made them angry. This was to test how emotion impacts decision-making. They then watched the videos. All participants were shown one video at a time. They had to share how confident they were from 50 to 100% that the video was real or a deepfake. The videos we used included 4 videos of Kim Jong-un and Vladimir Putin, 2 of which were fake. We then showed participants what the model predicted and allowed them to change their answers. This way, we could see whether human decision-making was impacted by machine predictions. The machine learning model assessed 50 videos from a dataset of 4,000 videos. In both experiments, we included interventions. These included obstructed faces and inverted videos, videos shown upside down. We did this to see if the way our brain naturally recognizes faces changes our ability to identify a deepfake. Results. Experiment 1. The leading machine learning model correctly identified 65% of the videos in the dataset. 82% of participants outperformed the machine learning model. Participants were better at detecting fakes in high-quality videos. When the video was inverted or of low quality, they were 5% less accurate. Experiment 2. Recruited participants identified deepfakes 66% of the time. Non-recruited participants identified deepfakes 72% of the time. The leading machine learning model correctly identified 80% of videos when shown 50 videos from the dataset. When shown the entire dataset of 4,000 videos, the model achieved 65% accuracy. Participants who wrote about things that made them angry were quicker to judge a real video as a deepfake. The machine learning model was better at detecting low-quality deepfakes, such as grainy, blurry, and inverted videos. Participants were more likely to change their answer if it was different to the model's answer. This usually made them more accurate, except in the case of the political leader videos. The machine learning model was incorrect about both real videos of the political leaders. Meanwhile, 64% of participants correctly identified the videos of political leaders. Figure 2 shows human performance compared to model performance. On the x-axis in the graph, you can see results from experiment 1 on the left in orange. The model overall is on the left and the participants on the right for this experiment. The results from experiment 2 are in purple on the right. From left to right, they show the results of the model, the recruited participants, and the non-recruited participants. On the y-axis, you can see the accuracy of the different treatments as a percentage. Looking at the graph, which group of participants performed best in experiment 2? Discussion. Our results suggest that people are as good at identifying a deepfake as the leading machine learning model. Participants were better than the model when it came to the 4 videos of Kim Jong-un and Vladimir Putin. This could be because we can think critically about the content beyond the visual clues. The machine learning model was pretty certain that the authentic videos were deepfakes. This leads to questions about the model's ability to analyze the context of a video. Emotion does seem to impact human decision-making by decreasing our accuracy. Therefore, deepfakes that provoke emotion may be harder for us to detect. In experiment 2, participants could change their initial answer after seeing the model's response. This helped participants improve their accuracy in most cases. However, it also led them to change their correct answers. This suggests that human-machine collaboration might not lead to more accurate results. Conclusion. The good news is people appear to be good at detecting deepfakes. The bad news is that deepfakes will likely get more difficult to detect over time. However, we can take action. Humans are better at thinking critically about the content and context of the video. Always think before sharing viral videos, especially if they make us angry or upset. We can tell our friends and family to be careful too. Thank you for listening to this recording. This work has been adapted from the original peer-reviewed paper in the journal PNAS, published on December 28, 2021. Research conducted by Matthew Groh, Ziv Epstein, Chaz Firestone, and Rosalind Picard from the Media Lab at MIT and the Department of Psychological and Brain Sciences at Johns Hopkins University. See the full list of affiliations in the accompanying PDF. Please visit our website, sciencejournalforkids.org, for more free science teaching resources.